So this in this lesson we are going to have a look at probability rules. So basically we have 8 of them, and then we are going to see how each of those rules is derived. So the first rule is we have probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Then we are going to look at probability of A is probability A intersection B plus probability A intersection B prime until the last rule. But we can basically first look at their derivation, and then we go ahead to use them. So let me share. Yeah. So as I wait for as we load the whiteboard, is everyone able to see the whiteboard? Are we able to see the whiteboard?
Yes, teacher.
Hello? Can I get your response? Can I get your response so that we can continue?
Yes, teacher.
Were you seeing the whiteboard?
No, teacher.
Yes.
Teacher, I'm seeing it. Me, I'm not.
Okay, it's loading. Okay, are we able to see it?
Yes, teacher.
Okay. So we are going to
Yes, teacher.
okay. We are going to start so do you still remember this from our O-level math? These Venn diagrams?
Yes,
Yes,
teacher.
teacher.
Okay, so this is the universal. So we have number of universal. For this case, it is not known. Then we have number of A. We have number of B. And then what is this region here? To our left? What is that region to our left?
A only.
It is? Okay, let's begin from the middle part, where the two sets are intersecting. How do we call that region?
The intersection.
Okay, the intersection. So we represent it by A intersection B. Then this on our left?
A only.
A. So we call this region A intersection B complement. So why we call it B complement is because part B is not part of it. Okay, so it only shows us the members of set A and not members of set B. Are we there?
Teacher, why not A only?
Yes, this A intersection B is another way of saying it is A only. Because here we are looking at members who are only in set A and not in set B. So that is how we write it. So it can be written as A only or A intersection B complement. But now, since we are in advanced level, we are going to be calling that area A intersection B complement. Is your question answered?
No.
Wow, sure. Okay. The A intersection B complement means that we are only having members of A, like we have said A only, so we are only having members of A and not members of B. So that is why we represent it as A intersection B complement. So the B complement means that members of set B are not part of it. Is it now more clear?
Okay, teacher.
Yes.
Yes.
Then we go to our right. How shall we represent that area?
A complement.
So it's going to be A complement intersection B. So this simply means that it is only members of set B that are part of it. So the rest, the A is not. Then how do we call this the area outside the two Venn diagrams, but inside the universal set? How do we call that area?
A union B complement.
Yes, A union B. Complement. Thank you. Now, we are going to begin with the, we remember with the, we said the probability of an event is equal to number of event. We divide this by number of sample space. Isn't it so? So we are going to begin with the
Yes, teacher.
number of, yes, please. Any questions?
No.
Okay, I can proceed. So, we are going to begin with the number of A union B. So if we want to find the union of A and B, what do we add? Hello?
A intersection B complement plus A intersection B plus A complement intersection B.
So we add these three. That is okay, thank you. And any other? So I'm saying we are going to add number of A intersection B complement plus number of A intersection B, then plus a number of A complement intersection B. Is that what you said?
Teacher.
Is it what you said? Any alternative
Yes,
method?
teacher.
Okay. Any alternative method of how we get A union B? Oh, okay. To make our work easier and to build our formulas that we were interested in, we are going to add. We are going to say number of A union B is equal to number of A plus number of B. Then after doing that, we are going to, just a moment. Okay, so we realize that when we add number of A and then we add number of B, there is some item which is A intersection B that we are going to add 2 times. Let me repeat that. So when we add number of A and also now add number of B, we are repeating A intersection B 2 times. So for that matter, we are going to subtract it so that we only add it once. Is that understood?
Yes, teacher.
Okay. So because of that,
Teacher,
so
no.
No.
okay, I am saying our first
This is kind of
probability rule was that probability of A union B is probability of A minus probability B minus probability A intersection B. So we are going to make the work of A union B simpler. We add number of A, which is this first set. Then we add their number of B, which is still this second set. But then when we do this addition, so remember, one of us told us we are supposed to add A intersection B prime plus A intersection B plus A prime, A prime intersection B. But now, because we want to simplify our work, we are saying instead of writing A intersection B, instead of writing number of A intersection B plus number of A intersection B. So we replace A or this by number of A. Is that understood?
Yes, teacher.
Then still to add adding A intersection B and A prime intersection B, number of A prime intersection B, we are replacing this by number of B. So when we decide to use A and we write it here, then the probability of B, we also write it here. Remember when we add this and this, we have added A intersection B. Let me change. So we shall have added this and this 2 times. Is that understood? So because we have added them 2 times by using number of A and number of B, we must subtract one of them so that we remain with only one. So that we literally remain with A intersection B prime, A intersection B, and then A prime intersection B. So that is what we are literally doing. Any questions regarding that explanation? Any questions?
No, teacher.
So I can
No,
proceed.
teacher.
Okay, so because our interest is probability, we are going to divide each term here by number of the universal set, okay? Because it will be our total. So we're going to divide here by number of universal, number of universal, and then lastly here also number of the universal set. So when we get number of A union B and we divide that by number of the universal set, this gives us probability of A union B. When we get number of A and we divide it by the number of the universal set, this gives us probability of A. Then we add number of B divided by number of the universal set. That gives us probability of B. Then we subtract number of A intersection B divided by the universal set. That gives us probability of A intersection B. So that is how we come up with our first probability rule, which is probability of A union B equaling probability of A plus probability of B minus probability of A intersection B. Any questions regarding the first rule?
No, teacher.
Okay. Then we can go ahead to look at another rule. So if we are interested in getting the probability of A, what will number of A be equal to? What will number of A be equal to?
A
Yes.
number of A intersection B complement plus number of A intersection B.
Good. So we are going to have number of A is equal to number of A intersection B complement plus number of A intersection B. So let me add this. So what we are going to do, so we had number of A is equal to number of A intersection B prime plus number of A intersection B. So since we are aiming at creating probability, so our definition of probability of E is number of E divided by number of sample space, which is the universal. So we're going to get this equation that we have, and we divide it by number of the universal set. So we're going to have number of A divided by number of the universal. This is equal to number of A intersection B complement. Divide this by number of the universal. Then we add number of A intersection B. Still this we divide by number of the universal set. So what is number of A divided by number of the universal? Number of A divided by number of the universal. Hello? So from our definition of probability of E, which is number of E minus divided by number of the sample space. So number of A divided by number of the universal set is going to give us probability of A. We say this is equal to number of A intersection B complement divided by number of the universal. So this is going to give us probability of A intersection B complement. Then we add number of A intersection B divided by number of the universal. This gives us probability of A intersection B. So this is going to be our second rule of probability. Any questions?
No, teacher.
Okay. So in case you have questions, you can please raise your hand up or you type in the chat section. I'll be
No,
able.
teacher.
Okay, so we go ahead. So we can slightly go back to page 1 to be able to get. Now, what will probability of B be equal to? Okay, there's someone who says they can't see me writing. Is it true that the screen has frozen?
No, teacher.
So you're able to see. You're able to see what I can write.
Yes, teacher.
You're telling her to first leave, but it's okay. Let me stop sharing and then share again, and then I think she will be able to see. Know that we now have, let me look for the whiteboard we were using. So I guess we are now able to see.
Yes, teacher.
Okay. So when we go back to our first page, I was inquiring now for probability of B. So if we're interested in getting number of B, what do we add? What do we add if we are interested in getting number of B?
A intersection B plus A prime intersection B.
Thank you. So we are going to add number of B is equal to number of A intersection B plus number of A prime intersection B. Then, since we are dealing with probabilities, we are going to divide each term there by number of the universal, being guided by this formula here, which is probability of an event is given by the number of events divided by number of the sample space. So we're going to divide each term by probability of, by number of the universal. So number of A intersection B divided by number of the universal. Then we add number of A complement intersection B. Still divide this by number of the universal. So number of B divided by number of the universal, that gives us probability of B. Number of A intersection B divided by the universal, it gives us probability of A intersection B. Number of A complement intersection B divided by number of the universal gives us probability of A complement intersection B. So this becomes our third rule. Of probability. Any questions? Any questions so far?
Teacher.
Yes, please. So that means we can proceed. So we have so far seen how to derive three. We have derived the three probability formulas. So let me introduce another one now. So we are going to this time draw one circle, and then so if we have if this is the if this is A, if this is A, why is this doing like this? So if we have A here, so which is the whole of this inside part, okay? What will be the area outside A? How do we write the area outside the set A? Hello? How do you write area outside A? Because we have said this is set A. So anything outside that set, it becomes A prime. Out there? Then this would still have the universal, which is not given. So we can say this is number of A. Then this is number of A. Oh, okay. It seems there's a challenge with this screen. Let me change back to okay, let me change Becky so that you can be able to see. Let me stop the So we have so far covered the first three. These two, it's just a matter of changing. If we have a prime, so we change where we have probability of A, we attach the prime where the A is, and likewise for B. So we were deriving the 6, but let me go to the next slide and then we proceed. So we had finished this. Okay, so we were here that if we have a set which has A, it's just one set, then the area outside the set A is going to be A prime, but then it is under a universal set. So it's under a universal set. So when we are adding, we say number of A plus number of A prime is equal to number of the universal set. Then we divide by number of the universal set for us to create probability. Even here we divide by number of the universal set. So when we get number of A divided by number of the universal set, this gives us probability of A plus number of A prime divided by number of the universal. This gives us probability of A prime. And we say this is equal to 1 because number of universal divided by number of the universal. So that will give us 1. So we shall end up with probability of A plus probability A prime is equal to 1. So likewise, if it is B, is also going to be probability of B plus probability of B prime, and this will still be equal to 1. So the simple explanation to this is that if we have two scenarios that are going to happen, so probability of B may be that it's going to rain, then B prime, it is not going to rain. But when we add their probabilities, that gives us a 1. So that is how we can explain the B and the B prime. So B is the probability of an event happening. B prime is the probability of that event not happening. So when we add the two, they are supposed to give us 1. Any questions before we proceed? Any questions? Have we understood? Hello.
Yes, teacher.
So we continue.
Yes, teacher.
Okay. Then we have these last the last two. We are going to show on our Venn diagram the areas that are shown by when we shade A union B, complement, and then A prime intersection B, B prime. So we are going to draw two Venn diagrams. Then maybe we enclose them. So we indicate our A. So this is number of A. This is number of B. And then up here we have number of the universal. So we are going to shade the area A prime and also shade the area B prime. So A prime, we said when we are shading it, it's an area which is outside set A. Then the B prime is also going to be an area which is outside set B. And then after we have shaded, we identify where we have double shading. So can we do that in like a minute? We draw the Venn diagram, then we shade area A prime, and we also shade area B prime. Can we do that in a minute? Okay, which area are you getting the double shading? You can just unmute and then tell us. No, I was talking, but you people today have become silent. I don't know why. I was asking, there's someone who finished. I was asking her to tell us what, but I think unfortunately, because of network, she might have left. She's not on Zoom. Okay, she's getting back. So I was telling her to explain to us how she has got the work. Anyone else who is done with the shading? The instruction was we shade area A prime using a different pattern and B prime using different pattern. Then where we have the where it would be like double shading, then that is the area we are interested in. So I've got only one of you who said they finished. So I'm waiting for the rest to finish as well. Okay. So since most of us have become quiet, I think let's proceed. Let's not waste time. So from my Venn diagram, we are saying on the Venn diagram, we are going to shade area A union B is inside the two sets. So when we are interested in shading A union B, okay, so on the Venn diagram, the area A union B is the area inside the two sets. So this is the A union B. So if we are interested in shading A union B complement, that means it is the area that is outside the two sets. So this area that I've shaded with green, so that is the area that is A union B. And then we go ahead to illustrate now A complement intersection B complement using shading. So where we have to first shade A complement, and then we shade B complement, and this intersection means we look for an area where these two appear together. So according to what I have, so this is A, is the area which shows A complement. Are we there? So we shade the area A complement with the blue color, like I've indicated here. Then we shade the area B complement with the red color. Okay. Now, if we separate these two, okay, this A complement shades B and then outside B. Then B complement, it shades part of set A and area outside the two sets. So we now come to conclusion that where we shall have the area that has double shading is area outside the two sets. So in other words, that is going to prove to us that probability of A union B, or before we go there, complement is equal to probability of A complement intersection B complement. But how it comes about, because number of A union B complement is the same as number of A complement intersection B complement. So what we do here, like we have done previously, is to divide by number of the universal, and as well here to also divide by number of the universal. So this will generate for us probability of A union B complement equaling to probability of A complement intersection B complement. So that is how we come up with that third rule. That rule. Any questions? So let me do the last rule and then we do some few examples. Yes, there is a message in the chat. Someone says they're not seeing what I've just written. Oh, sorry about that. But the explanation is here. Maybe if I can go a bit back. So we began by explaining or by shading A prime with the blue color, like you can see in the Venn diagram. Then it is followed by shading the area B prime with the red color. I don't know whether that is red. So that is that. So when we get the area that has double shading, okay, area that has A prime and also has B prime, which is the area outside the two sets. So this area is going to be representing A union B complement, but we have got it by shading A complement intersection B complement. So we say that number of A union B complement is the same as number of A complement intersection B complement. So when we divide by number of the universal, and still here we divide by the number of the universal, this gives us probability of A union B complement equaling to probability of A complement intersection B complement. So that is what I've just written. So can we proceed? Okay, then we are going to summarize our probability rules with we call this a contingent table. So when we are writing it, we draw a table. So we can draw our horizontal line and the vertical line as well. Then we add in more too. So we say this is A, this is A prime, this is B, this is B prime. Then this area here, this intersection, this. So this is A intersection B. Then A prime intersection B. Then A intersection B prime. And then A prime intersection B prime. So for example, if we are interested in getting the probability of A, we are going to say probability of A is equal to, we say probability of A is equal to probability of A intersection B plus probability of A intersection B complement. Is that understood? If we are interested in getting probability of B, then we add along this line. So we say probability of B is equal to probability of A intersection B plus probability of A prime intersection B. So the same for the rest. So it's just a matter of following the rules here. So this is for B, this is B prime, this is for A prime. Then I should have added the one here. Probability of B prime plus probability of B is equal to 1. So still the same for A. So here we add like this, it gives us 1. Even here we add like this, it also gives us 1. So this contingency table is a summary of how we can remember the probability rules apart from the last two rules. So the last two rules, we are going to memorize them. So the more we practice doing the numbers, the more we are able to get those rules. Okay. So I think let's do like one example. We call it a night. So that is a simple summary of how that table may look like. So depending on your choice, you draw it. Okay, then we have types of events. So before we proceed, we can look at types of events. Who can read for us our first paragraph? By show of hand, or you can just unmute and read. Can I choose? Okay. Okay, unmute and read for us, please. Enzia, you can please unmute and read, okay? Hello, I'm not hearing.
Two events that say probability
Mutually
of both events occurring at the same time is 0,
exclusive.
i.e., probability of A intersection B is equal to 0.
Okay, we are saying for mutually exclusive events, the two events are said to be mutually exclusive if the probability of both events occurring at the same time is 0. So in that, we are going to be equating their probabilities to be 0. So like if we are using this formula, probability A union B is probability A plus probability B minus this. So for mutually exclusive events, this will be a 0. So meaning we shall have probability of A union B equaling to probability of A plus probability of B. This only works for mutually exclusive events. Okay, someone to read for us. Becky, read for us our second statement.
Independent events. Events A and B are independent, then the occurrence of one does not affect the other.
Okay, the occurrence of one does not affect the other. Kenzia is asking what are mutually exclusive events. Maybe if you wanted us to give some examples, but you're saying these are events that do not occur at the same time. That is the simple explanation. They are events that do not occur at the same time. So what examples in life cannot occur at the same time? We can brainstorm about them. What are some of those events that cannot occur at the same time? Okay. Can I be asleep and then I'm awake? Can it happen?
Yeah.
It can happen.
Winning and losing.
Come again?
No,
Okay.
winning
Yeah, there's someone who said winning and losing. Okay.
and losing.
Yes.
Winning and losing.
If you are in a game, you either win or you lose, but then you cannot win and lose. Okay. So those are examples of mutually exclusive events that they cannot occur. We do not have a possibility of them occurring at the same time. Okay, we proceed. We say the independent events are in the events whose occurrence where we have an event occurring and it does not affect the other, or it does not prevent the other from occurring. So for this, the probabilities, the probability of A intersection B, we just simply multiply the individual probabilities. So multiply probability of A and probability of B. Then we have mutually exhaustive events. These ones, when we add, they obey the probability rule that if we add probability of A plus probability of B, they give us 1. That happens for mutual exhaustive events. I think for today, let us stop here. We shall meet again to do some examples of what we have discussed.